So to preserve that ratio, 5 to 7, we just think of one angle is 5x, the other one angle is 7x. So 5x plus 7x must equal 90? Wait. Was yours 8 to 7? Oh, okay. I probably just have an old addition up here. All right, so one of them should be 8x, and then one should be 7x, and then you come up with 15x equals 90, x equals 6, and then you just have to do your 7 times 6 to get one of your angles, which is 42 degrees. The other one is 8 times 6, which would be 48. Your smaller one's definitely the 42, so 42 is your answer. Questions on that one? We all got it right, but just in case. All right, then questions from the homework. Yeah, Will. What was that? 33B? All right. Let's see if I still have mine, or we'll just go through it. Oh, here it is. All right, 33 and 33B go together pretty. A and B go to hand in hand, kind of. So the first question, I'm going to go through A. It says, how many hits has he made? Well, it said his batting average right now is .32, which is 32%. He has been at bat 325 times. How many has he made? So you can either take 325, multiply it by .32, but what I did is I multiplied it by 325 times 32 over 10. That is his proportion. His proportion is... Our ratio is 32 over 100. That's what .32 is, and that gave us 104 hits. And so the same player goes into a slump and doesn't get any hits at all in his next 10 at-bats. Well, I don't care about that. I'm going to set up right now a ratio of his hits to how many attempts he's had. Well, he hit 104 balls. That's what we got from this one. And he had 325 attempts. That came from this problem too. So he had 144 and he had 325 attempts. Now it says the next 10 at-bats. The next 10 at-bats, and I kind of cut mine off. So the next 10 times at bat, what is his current batting average? So he's going to hit. Oh, he doesn't get a hit. There we go. He doesn't get any hits on the next 10 times at bat. So the number of hits stays the same. He didn't hit any of the next 10. However, he had 10 more attempts. So that means rather than swinging at 325 balls, he now swung at 335, but he still has the same number of hits. And then it's just 104 divided by 335 equals .31. 0, because this is the nearest thousand. Does that make sense? Will, is your other question? Okay. Bye. 34 says a basketball player has made 24 points out of 30 free throws. She hopes to make all of her next free throws until her free throw percentage is 85 or better. How many consecutive free throws will she have to make? So let's go ahead and take a shot of this. So currently, she has 24 that she made out of 30 possible attempts. And then she said she's going to keep shooting and she's going to keep hitting them. So if she makes 31 attempts, she'll hit 25. If she hits 32 attempts, then she'll hit 26. Like, are you paying attention at all? Okay, you asked. So that means every time she shoots, she has to make the shot. So we don't know how many times she needs to shoot, so it's going to be 30 plus X. That's how many attempts she's going to have. Well, for every one she shoots, she's going to also make it. So the top has to be 24 plus X as well. So as she shoots and she makes it, we have a formula like this. Well, she wants to be greater than or equal to 85%. Well, that's 85 out of 100. So I just set these kind of equal to 85 out of 100. I use cross multiplication, which we'll talk about today, and you just solve for X. And X needs to be 10, or it can actually be bigger than 10. So really that could read X is bigger than or equal to 10. Either way suffices because of the way it is. Just says how many consecutive free throws would she have to make. Has to be 10, but she could make more. I'm sure she'd be okay if she keeps making free throws. Questions on any of those steps? Because that's probably the most complicated problem on there. We're okay on that one? All right. Any questions on any other ones? Okay, then we'll get into today's lesson. We actually had them all up here. What happened to today's lesson? Who deleted today's lesson? Lyth, was it you? All right, the first thing we're going to talk about is something called the means extremes. Well, it actually is a theorem, but we've already used this before. We've already used it, we just never called it the means extremes because we never dealt with proportions or ratios. So the first and last terms of a proportion are called the extremes. Extreme means like the most. You're the first, you're the last, you are the extreme. The middle terms are called the means. Well, so in our first example, if I have A to B equals C to D, that's a proportion. That's a proportion, and our last two are called our extremes. And the middle two are called our means. Once again, if we had numbers in there, our 6 and 3 would be our extremes. And that 9 and 2 would be our means. When it's set up as fractions, it stays the same. That 6 and 3 are still your extremes. So this 6 and this 3 are still your extremes. And that 9 and that 2 are your means. So that 6 leads us off. 6 over 9 equals 2 over 3. That 3 ends it. So 6 and 3 are our extremes, and 2 and 9 are our extremes, or our means. All right, means, extremes, property of proportions. The product of the extremes equals the product of the means. So if we have something that's like A over B equals C over D, then we can say that A times D equals our B times our C. A times D are our extremes being multiplied, and this B times C are our means being multiplied. Did we ever see this before? What did we call it before? We call that means extremes. Because you've done this before in algebra. You've done this where you had two fractions set aside, and you can take your two ends, multiply them together, and that equals the 2 right here. Like, you call it what? Oh, you call it the means extremes? Yeah. Okay. So that's your means extremes property. Sometimes you'll hear it as cross product multiplication. Do you remember hearing that term at all? Some of us yes, some of us no. So let's just say also known as cross product multiplication. And if you didn't hear that term in Algebra 1, you'll hear it in Algebra 2, for sure. It just means extremes, just doesn't come off the tongue nicely, but cross product kind of does because you just cross and multiply. All right, let's talk about some properties that we can use with the means extremes. So our first property is our normal means extremes, and that is the fact that A times D equals B times C. We just did that up above. You can also switch the means. So you can switch the means. And so if I had A over B equals C over D, we could just switch the B and the C, which would result in A over C equals B over D, and everything still holds true. So we can just switch our two means, and the statement is still true, as long as that first statement was true. The next thing we can do, we can take the reciprocal of both sides. So the next thing is called taking the reciprocal. So if I started with A over B equals C, that's not a C, C over D, we're just going to take the reciprocal of both fractions, and that's going to lead us with B over A equals D over C. The last one we're going to talk about is adding the denominator. So this is going to be called add denominator. And once again, we're going to start with A over B equals C over D. But this time we're going to add the denominator to both sides. Well, you're not allowed to just add a number to both sides. The only thing you can do to keep it balanced is you have to add 1 over 1, kind of. But on one side we can add B over B, as long as on the other side we add D over D. Then everything stays balanced because I added 1 to both sides. So everything stays balanced. And we'll have something that looks like A plus B over B equals C plus D over D, and everything is still balanced. So once again, we can do our cross product or our means extremes. You are allowed to switch your means between these two places and everything stays balanced. You're allowed to take the reciprocal of both equations, and you're allowed to add the denominator on each side. So in this case, it'd be the denominator of the left-hand ratio, and then add the denominator of the right-hand ratio. Make sure you do it top and bottom. So you'd have A plus B over B equals C plus D over D. The last thing we're going to talk about with proportions and equality is, if you know that A over B equals C over D, oh yeah, Ethan.
The denominator doesn't matter which one you have.
Yes.
So it has to be bottom, bottom, or top, top. Like
So this has to be A plus B. A plus, this is denominator.
maybe like A over A plus A over B
A over A.
instead of the B.
No, because we're adding, this is a rule that helps us out. It's just adding the denominator. This is a numerator. That'd be adding by the numerator. So we have to do the denominator. It has to be the B. It'd be true that we could add the numerator of both of them to both, but then it would look like 2A over A plus B, which isn't going to help us anywhere. Oh, in fact, we couldn't add that because you have to have a common denominator to even add. So we'd have to do a whole bunch of work. So no, we're just adding the denominator there. All right, if I know that A over B equals C over D equals E over F, then A plus D plus E plus whatever equals, or divided by, B plus D plus F, so all of the denominators being added, it will equal what we started off with. So an example of that would be, well, let's say I have 1/2. 1/2 is equal to 2/4, which is equal to 4/8. Well then, by this principle, 1 plus 2 plus 4 over 2 plus 4 plus 8 is just going to equal 1 over 2. Because all those ratios are preserved. And in fact, because if you did the math, it'd be 1 plus 2 plus 4 equals 7 over 2 plus 4 plus 8, which equals 14. 7 over 14 is 1 over 2. So as long as you know these are equal, adding the numerators and adding the denominators, you'll end up with what you started with. All right, we're going to use proportions to complete each of the following statements. So our first one starts off with 5 times y. Well, those are our two means being multiplied. Well, if my two means are being multiplied, they're going to equal my extremes being multiplied. So 5y is going to have to equal 2x. All right, our next one is x plus y over y equals, who wants to give a shot at what that one's going to equal? Yeah. Y plus x over x. No, we have to do something with this other one. I'm just trying to see where that came from. Like? It'd be 5 plus 2 over what? 4. It would be 5 plus 2 over 2. It'd be 5 plus 2 over 2. This is the one where we added the denominator. So this one we added y plus y to give us x plus y over y. So we do the same thing here. We add the denominator to the top and bottom, which is going to be 5 plus 2 still over 2, because we keep our denominator the same. All right, next one is x over 5 equals what? What of those properties are we using to make that equal? Yeah, Sam.
Y over 2.
It is going to be y over 2. Because if we look at this, all we are is flipping our two means. This mean got switched with this y, so the y now gets moved over here. That was switch the means property. Our last one is 2 over 5. Ethan. It's going to be y over x. That is our reciprocal. So once again, this was our means extremes. This was add our denominator. This was switch our means. And this one was reciprocal. So those are all 4 of our possibilities. I want you to do that exact same thing on these problems. Now, they're straight out of the book, so that's why the numbers aren't 100% the same. So these are straight out of the book. Give them a shot right now if you haven't already. I'll give you some time to work on them, and then we'll go over them together. All right, let's go over these and see how far we got. All right, for number 3, it says a over 2 equals 2 over 3. Then 3a equals, what is 3a going to equal? Yeah, Tyler. It's going to equal 4. Because it's 2 times 2, right? And real quick, would that be means extremes? Would that be switching your means? Would that be your reciprocal? Or would that be adding your denominator that you used there? It probably won't be the reciprocal, because look at what we did. What was that? Because we took 3 times a, and we did 2 times 2. So that looks an awful lot like our means extremes, doesn't it? Because our means extremes was our a times d equal to b times c. All right, so that would be our means extremes. All right, next one we have c over d equals 4 over 7. Then d over c equals what? Sahaj. 7 over 4. And what let us do that? Which one of those things? Reciprocal. Yep. Awesome. All right. Lyth and Tyler off the... I'm not Lyth. Sahaj and Tyler off the hook. Next one, we got E over F equals 5 over 9. Then E over 5 equals what? Lythe. F over 9. And what property let that happen? You can turn the page. We only have 4. Switch the means. Yep, we switched the means. We just switched that F and that 5. Our next one is G over H equals J over 8. Then J over G equals what? What'd you get, Will? 8 over H. What do we do there? Do you know how you did it? Not quite the reciprocal, right? What was that? This one's a little different, right? So I think the easy way to think about this is maybe actually do your means extremes, in case you didn't get this one, and do your G times 8 equals your J times H. And then you would just look at, well, to get J over G, you'd have to divide both sides by G. And then you have to divide both sides by H to get your H over there. So we're actually using the means extremes and just moving stuff around. Kind of. Stephanie? Oh, nothing? Oh, okay. Number 7, we have K over M equals 2 over 3. Then K plus M over M equals what? Sam?
5 over 3.
5 over 3? I'm going to write it as, you are 100% right. I'm just going to write it as 2 plus 3 over 3 so we can see it as that adding that denominator. But 5 over 3 is 100% awesome. All right, number 8 says N over P equals Q over R equals 7 over 9. Then N over P plus, or N plus Q plus 7 all over P plus R plus 9 is going to equal what? There's actually a bunch of correct answers here, but there's one I'm looking for. Megan? N over P, 100% correct. I'm looking for a different answer, though. That is 100% correct because N over P would be correct. Can anyone think of a different answer that we could use? Well, can we focus on this real quick? Lythe. Q over R, 100% correct. What else could we write it as? So Hedge. 7 over 9. All of those are correct. Most likely the 7 over 9 would be the most useful because that is a number. All right? But N over P, the way this question is structured, N over P would be correct. Q over R would be correct. 7 over 9 would be correct. In fact, N plus Q over P plus R would be correct. N plus 7 over P plus 9 would be correct. Any of those combinations would be correct. But most likely on like a test or something, 7 over 9 would probably be the answer I'm looking for, and I'd structure it a little differently. All right, our next one says, if 4 over y equals 7 over 9, then blank equals blank, and then y equals some number. What would most likely go in those two blanks? Anyway, yeah. 7y equals 36. Perfect. So we use the means extreme. 7y equals that 36 because that's your 4 times 9. And what does y equal then? Y equals what? Y. Y and 1?
No, y equals, yeah. I don't know.
I don't know what you're saying.
1 and 1 over 7.
Oh, 1 and 1 over 7. Sure. I'm just going to put it as 36 over 7. I thought you said y equals y and 1/7. I gotcha. Oh, it would just be 36 divided by 7. And you could do the math. All right, our very last one says b over a equals t over x. And a over b equals what over p. So what can we conclude about x? Yeah. Oh.
Put in other answers. Or is that like
It's the only way answer to solve for y. It really is the only answer to solve for y.
the answer? So I put in 4 equals 7. Y equals
You put, say it again?
9. 4 equals 7. Y equals 9.
That is not true. Four does not equal 7, and y does not have to equal 9. Because 4 can never equal 7. Because if I give you $4, are you okay giving me 7 back? No. So we have to use the means extremes. That one's just asking how would you solve for y, and that would be the means extremes. Our next one says, what can we conclude? Did anyone conclude anything from that statement? Sam?
P equals T.
P equals T. That is correct. We'd have P equals T. And where that came from? Well, if we look at what happened between these two, this A and B switched places. So we took the reciprocal to get the A over B there. So that B and T need to travel together. Well, the problem is this T took P's place, or this P took T's place. Because if I took the reciprocal here, I would take the reciprocal on the other thing. So we are flipping this, which means we would have to flip that, which means that T and P are occupying the exact same space, so P has to equal T. Questions on that one? All right, the rest is homework. If you look at the first few problems, you're going to be using that means extremes to complete the statement. So in the beginning, you're going to have something like 5x equals 6. Oh, I'm sorry, yeah, 5x equals 6. So we're going to solve those. And then moving on, you're going to get bigger and bigger and bigger using basically that means extremes. Basically, all these problems are means extremes. There are some factoring problems, and there are some solving systems in there. So work carefully and work diligently. It keeps kind of scaling up. Will.